Welcome back to Dr. Zakir Math. This is the place where you can learn math in an easy way. Today we will solve the equation x minus cosine x is equal to 0 in the interval 0 comma pi by 2 using Newton's method for how many places? For accurate to 10 to the power of minus 4. It means you have to fix your calculator. How many decimal places? 4 decimal places you have to fix it in the calculator. Yes. And I will show you step by step how to reach the solution accurate to 10 to the power of minus 4. Let's make simple. Okay, let's get started. Right. What is Newton's algorithm? Already I posted 2 videos. Okay, please like the videos. The algorithm is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. But this one we are not going to type in the calculator. On the calculator we will type our own formula, right? Yes, same formula but in a different way. Yes, let's go to the solution. Right, now the equation is x minus cosine x is equal to 0. So far I gave you cubical equations and fourth degree equations. Now it's an equation x minus cosine x is equal to 0. We cannot use equation mode here. So how can I find the answer, teacher, before I start the method? Yes, what you need to do, you just type this equation. Type the equation as it is like in the screen. X minus cosine x alpha equal to 0. Okay. And then press shift, then calc, and then press equal. Before doing this one, you need to fix your calculator for how many decimal places? 4 decimal places. If you fix this one, let us start. Alpha x minus cosine alpha x alpha equal to 0 equals, yes, I got 0.7391. Okay, this answer you have to get it. Already the interval is given, so no need to search for the interval. So f of x is equal to x minus cosine x. Let me put f of 0 and f of pi by 2. So far we worked out all the questions in the degree mode. For this question you have to use radian mode. For all the trigonometric equations, sine theta, cosine theta, secant theta, tan theta, everything 6 trigonometric ratios, whenever the question comes you have to use radian mode. Keep it in your mind. So please fix your calculator for radian mode. So f of 0, you just put x is equal to 0 minus cosine 0. You know very well cosine 0 is 1, so negative 1. F of pi by 2, you just put in the calculator pi by 2 minus cosine pi by 2, which is equal to 1.5708. Right. So the root lies between what? There is a change of sign. Can you see that? Negative and positive. So there is a change of sign is there. So root lies between 0 and pi by 2. Root lies between 0 and pi by 2. Okay, right. Pi by 2. So let us start. Absolute value of f of 0 is equal to 1 and absolute value of f of pi by 2 is equal to 1.5708. So absolute value of f of 0 is less than absolute value of f of pi by 2. The root is closer to what? 0. So the root is initially we are writing, just see the changes, small changes we will see later. Root is closer to 0, right? So I'm taking the initial approximation x naught is equal to 0.1. So on the calculator, what we are going to type it? On the calculator, for all the Newton's method, you are going to put x minus bracket open. And what's your f of x? Your f of x is x minus cosine x. So here you are going to put your f of x over, and here you are going to put your f dash of x. Okay, close the bracket. And what's your f of x? Which is x minus cosine x. And what's your f dash of x? X derivative is 1 and cosine x derivative is negative sine x. Negative is what? Positive. So you will get what? 1 plus sine x over here, right? Yes. Type this all in the calculator. Let's start. Okay. Alpha x minus bracket open and then fraction mode. Alpha x minus cosine alpha x and then 1 plus sine alpha x and then press calc. Okay, right. So let's make a small table x naught. Your initial approximation is 0.1. Press calc. 0.1, press equal. You will get x1 is 0.9138. Again press calc, press the answer. Answer key, press it. You will get x2 equals 0.7447. Again press calc, press answer, gives x3 equals 0.7391. Again press calc, again press answer key. You will get x4 is equal to, x4 is equal to 0.7391. So now you see here x3 and x4 has the same values, right? So we are going to stop it here. Once you get the same value, the next iterated value you have to stop it. So therefore the root is what? 0.7391. This is your answer. Now let me ask you few questions. Teacher, you said the root is closer to 0. So it should be less than 0.5, but you are getting more than 0.7391. What is the reason behind this? Let me tell you the reason for this one. Even though absolute value of f of 0 is less than absolute value of f of pi by 2, the root is not closer to 0. What is that? The root is not closer to 0. Why? The reason is because the function curves a lot. What do you mean by curves a lot, teacher? So far we get polynomial equations, straight line or x cube like this, okay? But the cosine x moving like this, right? So the function curves a lot. So the root is where the graph actually crosses 0, and for f of x equals x minus cosine x. That happens around what? 0.7391. Not at the end point with the smaller absolute value of f of x. The smaller absolute value of f of x rule works only for the function that change roughly in a straight line. So this rule will work out only for what? Roughly just a straight line or a small changes like this. If so many changes are there, the rule will not work out. Keep it in your mind. Sometimes it work out. Okay, keep in your mind. So in short, if I want to say this one, in short, what can I say? The root is not near to 0 because the function curves. It crosses 0 around 0.7391. Not at the end point with smaller absolute value of what? F of x. That's what I can say. But do I want to know all these things, teacher? Not necessary. But your work is finishing here. So the root is 0.7391. So this finishes here itself. So no need to concentrate on that. In general, you must know, but not necessary. Your work is to solve the question. You don't need to analyze the problem and all. Okay, right. So far I did 3 questions in numerical method, in Newton's method. Keep in your mind. So again I'm telling, please, if you like this video, please, if you really helpful, then please like this video. If you found this video helpful, again I'm saying don't forget to like, share and subscribe to Dr. Zahir Math. Remember, east or west, Dr. Zahir Math YouTube channel is the best. Okay. See you in the next video, and the next video is secant method, which is a nice one. Waiting for that one. Okay. Bye bye.